So we're gonna get started. Some people might join later, but we're just doing. All right. So the 1996 AMC problems. All right. Today we have some problems that are a little bit, they're kind of weird because they seem complicated and they seem like you have to do a lot of math, like what you would need a calculator for. But in reality, most of these problems you can do by logic, right? And you have to think a lot in order to make the math actually simpler. So it's kind of interesting. All right. So just like before, I'm going to give you guys about 8 to 10 minutes to solve the first set of four problems. And then after we can discuss, share our answers. So you may begin. If you just joined, we're just working on the first four problems right now. Three more minutes, guys. All right, finish up that last question that you're working on. Okay, let's move on. All right, how was that, guys? Do you guys want more time? I gave you about 8 minutes, but maybe you guys want more time. If you would type in the chat, that'd be great. You can private message if you want. Okay. All right. Seems good then. So, like always, what we're going to do here is we're just going to go over our answers. If you guys want to type out your answer or unmute and explain your response, that'd be great. But you can just give me your answer for now. So just type it out in chat if you want to say it, if that's easier. Your answers to problem 1. Okay. Yeah, mostly good. So let's go over this. This one's pretty simple. How many positive factors of 36 are also multiples of 4? So how do we approach this? Well, let's first find out what the positive factors of 36 are. So if we have 36, what are the factors? Remember, the factors are just the numbers that can multiply into 36, right? So let's start with 1. You have stuff like 2, 3. Does 4 work? 4 also works. 5 doesn't work. 6 works. 8 does not. 9 does. 12. 13. Or sorry, not 13. That's wrong. It'd be 18. And that's about it, or other than 36 itself. So that's all the factors of 36. Now, what are the multiples of 4? Well, let's go with 4, obviously. 8, 12, 16, 20, 24, 28, 32, 36. And anything higher than this won't happen because, well, the factors only go up to 36. So what it's asking is how many positive factors of 36 are also multiple also. So we're just trying to find ones that match, right? So let's see which ones match. Well, here we see we have 36, obviously. We also have, sorry. What else do we have? We also have 12. And we have 4 as well. And that's about it, right? Nothing else matches up, which means our answer is 3 because there's 3 factors, 4, 12, and 36. So if you got B, good job. That's the answer. That one was pretty simple. Problem 2, also not bad. Jose, Thuy, and Kareem each start with the number 10. Jose subtracts 1 from the number 10, doubles his answer, and then he adds 2. Thuy doubles the number 10, subtracts 1 from her answer, and then adds 2. Kareem subtracts 1 from her number 10, adds 2 to his number, and then doubles the result. Who gets the largest final answer? So we got 1C, I believe. Yeah. So how do we approach this? Well, their numbers are actually not connected, right? We're trying to find the largest out of them 3. So let's just calculate all their numbers separately. So I'm going to put J, T, and K to represent their names. They start with 10. Jose subtracts 1 from the number 10. Then he doubles that. So you multiply all this by 2, and then you add 2. So what is that? 10 minus 1 is 9. 2 times 9 is 18, plus 2 is 20. Okay? If we did the same for 3, we would get 21. Just simple math like this. And then for Kareem, we would get 22. So who has the largest final answer? Well, that's just C. Okay. Let's do the next one. The 64 whole numbers from 1 through 64 are written 1 per square on a checkerboard. So an 8 by 8 array of 64 squares. The first 8 numbers are written in order across the first row. So like this. The next 8 across the second row, same direction, and so on. After 64 numbers are written, the sum of the numbers in the four corners will be. So we want to find the sum of the numbers in the four corners. So how do we, let's figure out this layout first. It's going to look something like 1, 2, 3, 4, 5, 6, 7, 8. And then, as it says, we're going to go down, write the next 8, right? So on and on. So obviously, the first four corners, or the first two corners, are going to be 1 and 8, because the square is going to look like this. Right? And in the corner, we have 1 and 8. So now let's figure out what goes down here and what goes down here. Well, this is going to be the last number, which is 64. So we know that one. And for this one, we could just work backwards, right? We know this is 64, so you do 63, 62, 61, 60, 59. And by the way, I'm matching it up to here so I don't lose track of where I am. And then that is 58 and 57. So alternatively, if you wanted to do this faster, you could just subtract 7 from 64 because that's how many numbers are in this row before 64. But you could always do this if you don't want to figure out the math. So now we have the four corners. The question is asking the sum of the numbers, right? So we do 1 plus 8 plus 57 plus 64. And we would get from this 130. So the answer is A. Also, if you guys have any questions, if you disagree with my answers ever, you can just ask and I will give you guys an explanation. Okay, so problem 4. Remember at the beginning of this meeting, I said something about today's problems being weird because some of them might look like you need to do a lot of math, but in reality, you don't. So at first glance, what this looks like is it's asking us to multiply 2 plus 4 plus 6 plus 8 plus 10 and on until we reach 34. And same thing on the bottom. So that would take forever and there wouldn't be that much time on the test, right? But we have to think smart and we have to find other solutions to sort of simplify the problem. So how I would approach this is find something in common between the denominator numbers and the numerator numbers. So what is common about the numerator? Well, I noticed that they're all even numbers. And the thing about even numbers is you can divide them by 2, right? So what if I just divided all of this by 2? So if I divided 2, so if I factored it out, sorry, Belle, were you talking? Or was that just background noise? Okay, it's fine. I think it was just background noise. But let's continue factoring. Okay, so 4 plus 5, and on until we reach 34 divided by 2, which is 17. Okay, now what's on the bottom? Well, I noticed that on the bottom, we can divide all of these by 3. So I can factor it out. 3 divided by 3 is 1. 6 divided by 3 is 2. And on, and on, and on. Until we get to 51 divided by 3, which is 17. Okay, so now this is simplified. But what we notice is that the top actually matches up completely with the bottom. And when you have a fraction, you can simplify the top and the bottom if they have the same factor, right? So this together and this together is the same factor. So we can just cross cancel it. And what are we left with? We're left with 2 over 3. Okay. So that's B. All right. So we had a question about the previous one. The previous slide. Let me see if I can get there. 1 second. So one of you guys asked, shouldn't it be B? So the reason why it's not B, well, we have to sort of check, right? So we have 1 in this corner. 8 in this corner is pretty obvious. And 64 in this corner is pretty obvious. Let's just redo it. Okay. So what is here? This is 63. This is 62. 61. 60, 59, 50, 58, 57. All right, this is a 7. So let's count how many are in this row. It's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 numbers in this row, so we know that this corner is 57, and we're correct about that. And these corners are pretty self-explanatory. So if we add them all up, I'll just do it actually this time. All right, I'll set it out. 64 plus 57, 121. And then we add 1 plus 8. So 121 plus 1 is 122, plus 8 is 130. So maybe you did your arithmetic wrong in this part. Maybe you counted this wrong. But yeah, just make sure, be very, very careful when you have arithmetic like this, because one wrong step could cause you the wrong answer. All right, so let's move on. I have 4 new problems on the board. Let's try doing it, and I'll give you guys 10 minutes this time. Also, keep in mind that on the AMC, as we go on, the questions are going to become harder, right? So question 1 might be really easy, and question 5 or 25 is going to be really, really hard. So make sure when you're doing the actual AMC, you're saving time for the last problems. But just work on problems 5 through 8 right now. Okay, halfway point, guys. All right, that's time. Okay. So, problem 5. Ooh, one sec. Okay, problem 5. What did you guys all get? I already got 2 answers for this actually. So, feel free to type it in the public chat or private chat. Either's fine. Yeah, mostly A's. All right, let's see what the question's asking. So, it's asking us these letters that represent points on a number line. all have like a specific value, right? And the idea is we're trying to find an expression out of these 5 that represents a negative number. Okay, so how do we approach this? Well, one method is we could sort of estimate the number that each of these falls on. For example, I could say that, well, maybe this is 3.7. I could say maybe this is negative 1.2. But after that, how would we do it? Well, we would have to plug these in and actually do the math. So remember what I said at the beginning of the meeting? Sure, you can do all the math, but there's always simpler ways to do it. So how I would recommend doing this is actually just using the rules of negative numbers. So it's asking which of the following expressions represents a negative number. So I can just try plugging numbers that seem like what they would be on the number line into this. So P minus Q. Well, I would have a negative number minus another negative number. So negative number. So this is a smaller negative number, right? So -3 or something minus a bigger negative number. And by bigger, I mean closer to the positive side. And then you would end up with -3 plus 1 because negative is plus. And that would give you a negative number. If you subtract a smaller negative, or yeah, if you subtract a bigger negative number from a smaller negative number, you always get another negative number. So it seems like this one is the answer, but I'm going to check the rest just in case we did something wrong there. So what about here? P times Q. P is a negative number, and so is Q. What happens when you multiply a negative number by another negative number? Well, you get a positive number, right? So this one's not it. What about this one? S divided by Q. S is a positive number. You divide it by a negative number, and then you multiply it by another negative number. So we have another negative and a negative, which creates a positive. Positive times positive is positive. So this is not right. Same with this one. We're going to end up with 1 positive, and on the bottom, 2 negatives. And then that becomes positive divided by a positive number. That'll give you another positive number. So if you don't really understand what's going on, really, I'm just going off the rule that if you multiply a negative number by a negative number, you get a positive number. And if you multiply a negative number by a positive number, then you get a negative number. So it goes the same way for division, right? Positive divided by positive is positive. Negative divided by negative is negative, or is positive. So this one, we have addition. So we're going to do S plus T, which is 2 positive numbers. So you're definitely going to get a positive on top, divided by R, which is another positive number because it's on the right side of 0. And so that's also a positive number. That's not correct. So the answer is just A. Really, what you could do is just do process of elimination, or you could see that A is the answer. And if you're running out of time or you're short on time, then you don't really have to check these. But if you do have a lot of time, you can check it just in case. So the answer for that was A. If you got A, good job. So problem number 6. What did you all get for your answers here? Type it in the chat. Okay. So let's see. What is the smallest result that can be obtained from the following process? All right, what's the process? Well, we have to choose 3 different numbers from this set. So any 3, we have to add 2 of those 3 numbers and multiply their sum by the 3rd number. Okay, so the first thing I'm noticing is what they're asking us to do is add and multiply. So our numbers can only increase, right? If you add, you get a bigger number. If you multiply, you get a bigger number because these are all positive numbers. So how do I want to choose 3 numbers so that I can get the smallest result? So I want to choose the smallest numbers, right? So 3, 5, and 7 are the numbers that I'm going to choose. So you could do some mental math and figure out what the smallest number is, but we're going to expand it. We're going to actually do the math. So multiplied by 7, 3 plus 7 multiplied by 5, or we could do something like 5 plus 7 times 3. So these are all the possible combinations, right, of adding and then multiplying by the 3rd number. So let's solve this. 3 plus 5 is 8. 8 times 7 is 56, I believe. 3 plus 7 times 5 is 10 times 5. So that's just 50. And then 5 plus 7 is 12. Multiplied by 3 is 36. So the answer for this one is C. Okay, so pretty simple after you identify what you're actually trying to do and the 3 numbers that you're trying to use. The hardest part really is trying to find out how do I approach this problem. But I realized that adding and multiplying can only give me greater numbers. So if I want the smallest result, I have to use the smallest numbers. All right. Next problem. Problem 7. Okay, so you can type your answers in the chat. In the meantime, I will read the problem. Brent has goldfish that quadruple, so become 4 times as many, or you multiply by 4 every month. And Gretzel has goldfish that double every month. If Brent has 4 goldfish at the time that Gretzel has 128 goldfish, then in how many months from that time will they have the same number of fish? Okay, so there's 2 ways that I say we could approach this. Number 1 is you could do it algebraically. So you could set up an equation for Brent's goldfish and an equation for Gretzel's goldfish, and then set them equal to each other. But that is a little bit advanced. I'm not sure if all of you have gotten to that yet. So we're going to take a simpler method, actually. I'm just going to draw a table. So B for Brent, G for Gretzel, and actually I'm going to do M for months. All right, so let's go down the table and just do this. So we know that Brent starts with 4 goldfish, and Gretzel starts with 128 goldfish. So what's our table going to look like? Well, both of them are just going to follow the amount that they double by every month. So I'm going to get started. Brent doubles or quadruples every month. So multiply this by 4, and then multiply that by 4 is 64. 64, 256. And then I'm not sure about this yet, so I'm going to go to Gretzel here. Multiply this by 2 because she doubles her goldfish every month. On month 3, she has 512, and on month 4, she has 1,200. So they're not quite equal yet. So I'm going to multiply this one by 4 again, and that would be 1,024, and this one would be, because I'm multiplying by 2. Okay, so not quite equal yet. I'm going to multiply this one by 4 again. So if you can't tell, I'm actually looking at numbers that I already calculated because calculating this might take a while. But we see that we all already have the same amount of goldfish on month 6. So the answer is C. So if you got C, good job. All right. Last one for this section. Points A and B are 10 units apart. Points B and C are 4 units apart. And then points C and D are 3 units apart. If A and D are as close as possible, then the number of units between them is one of these. So what it's asking is we want to put points A, B, C, and D in a configuration so that it meets these criteria, but at the same time, A and D are the smallest possible value. So we need A, and we know that the distance between A and B is 10. That we can't do anything about. However, the distance between points C and B, so B and C, is 4 units apart. So we could either go in this direction and say C is somewhere here, it could be somewhere here, maybe down here, and these would be 4 units apart. However, we don't want it to be this far, right? Because we want it to be closer to A. We want to keep everything as close to A as possible so that in the end, A and D can be as close as possible. So I'm actually not going to put C out here. I'm going to put C in the middle of the line right here. And the distance between C and B is still 4. And this is allowed because the distance between A and B is 10, the distance between C and B is 4. Okay, so now it says that the points C and D are 3 units apart. Again, I could put D somewhere out here, could put D out here, out here, out here, but that would be traveling further from A, right? And I want to be closer to A. So I'm just going to put D along this line as close to A as possible. And basically, the way this works is, as you guys know, the distance or the closest distance between 2 points is a straight line. So I want to put it back on this straight line. I'm going to put D here, and the distance between D and C is 3. Okay, so I'm going to draw this line again. We have D here because it's a bit compressed up there. C here and D, or B here. And then we have A here. And we know that distance between C and B is 4. Distance between C and D is 3. And now we just have to find the distance between A and D. So we know that A and B is 10. So it would just be 10 minus 3 minus 4. That gives us an answer of 3. So the answer is B. Okay, that's a little bit complicated, the way I explained it. But in theory, it's pretty simple. But if anyone has any questions, you can ask right now. There's no questions. We'll move on to the next section. And if there's any questions about the previous problems, 5 through 7 as well, you can ask. Okay. If not, we're going to move on. The next set of problems, I'll give you guys another 10 minutes to work on it. These are going to start to get a little bit hard. I'm gonna give you guys one more minute, guys. Okay, let's get moving. Number 9. So if you want to type your answers in while I speak, feel free. So the question's asking us, if 5 times a number is 2, then 100 times the reciprocal of the number is what? Well, how do we approach this? Well, let's look at the first part first. 5 times a number is 2, and we reference that number again later. So we don't know what that number is. So the first thing I'll want to do is set that number to a variable like x and solve for it, right? And I know that 5 times x is equal to 2. So what is x? If I divide both sides by 5, simple algebra, I get x equals 2 over 5. So that's that number. And then it asks, what is 100 times the reciprocal of the number? So what is the reciprocal again? If you don't remember, the reciprocal is just when you flip the numerator and the denominator of a fraction. So if I flip the numerator and denominator, 5 goes to the top, 2 comes to the bottom. This is the reciprocal of the number, and then I need to do 100 times of that. So multiply by 100, that is 1,000, not correct. And then after I get there, I can just solve. This is 500 divided by 2, and that's 250. So the answer is D. So not too much to that. Really, the only thing is make sure you understand your mathematical definitions and concepts like reciprocals, and make sure you don't get confused by all these numbers and fractions. Because when you're flipping it, you have to make sure you do the algebra correct, and then you have to flip it again. Just make sure you're being very careful when you do that. So the answer for that was D. For problem 10, the question asks, when Walter drove up to the gasoline pump, he noticed that his gasoline tank was 1/8 full. He purchased 7.5 gallons of gasoline for $10. With this additional gasoline, his gasoline tank was then 5/8 full. The number of gallons of gasoline that his tank holds when it is full is what? Okay, so we have a lot of numbers here, a lot of information. Let's mark out what we know first. We know that his gasoline tank was, keyword is was, 1/8 full. And then he purchased 7.5 gallons of gasoline for $10. With this additional gasoline, his tank was then 5/8 of the way full. So this is after, because we know it's then. So, and then what we're trying to find out is the number of the gallons of gasoline that his tank holds when it's full, right? So the total amount. Okay, how do we approach this? Well, we know how much he filled up his gasoline, or the precise amount of gasoline that he filled up his truck with, and we know how much he started with and ended with. So what I'm going to do is I'm going to subtract his ending amount by his starting amount, find the difference, which is 4/8, and that's basically 1/2. And this is the amount that he filled it up, because if you add 1/2 to 1/8, you get 5/8, right? So 1/2 is how much he filled up his tank by in order to get to 5/8. And then we also know that he purchased 7.5 gallons of gasoline for $10. So 7.5 gallons of gasoline is 1/2, because that's how much he purchased, and that's how much he managed to fill up. So if we know that 7.5 is 1/2 of the thing, then how much is a whole of his tank, right? So that's just 1/2 times 2 gives us a whole, and 7.5 times 2 is 15. So 15 gallons makes up his entire gas tank. So the answer is D. Okay, so you may have noticed that there was also this $10, And a lot of the times, the AMC will do this a lot. They'll give you red herrings, right? So pieces of information that you don't actually need to use, because nowhere in this question did it ask you about how much money that he spent. So just be careful you're not accidentally using this number, for example, instead of 7.5. Okay, let's move on. You can type your answers in as I talk. So we have a number x, and basically it's 0.0000 for 1,996 times, and then a 1 at the end. So a really, really small number with a lot of zeros. And then it's asking us which of the following expressions represents the largest number. Okay, so obviously we can't just do this. We can't just put this and write down 1,996 zeros after here. That would not work at all. Instead, what we have to do is we have to use our knowledge of arithmetic and how these numbers work. So I know that 3 plus x is just 3 plus this tiny number because it's 0. It's a tiny fraction. So we'll get 3.000 with that many zeros and then a 1 at the end. So just a tiny bit above 3. For b, put that here, that's just 3 minus it. So we'll get like 2.9999 all the way going down. And that's less than 3. So we already know that b is ruled out because it was smaller than a. Okay, so I'm ruling out b. Okay, so for c, it's 3 times this number. Okay, since this is a tiny number or a tiny fraction, we know that multiplying the fraction by 3 is just going to give us another tiny number, right? Because if I multiplied this, I would have this many zeros and then a 3 at the end, right? If I multiply 3, I would just have 3. All of these would stay 0. So this is still a tiny number, so I'm ruling out this as well because we actually have a number 3 here. Okay, so this next one is a little bit more complicated. We have 3 divided by x, and I might as well mention this one, x divided by 3. They seem similar, but they'll give us really different results. So what is 3 divided by x? So we have 3 divided by a tiny fraction, right? So absolutely tiny number, certain amount of zeros here. And at the same time, we have this tiny number divided by 3. Okay, let's take a look at this one first. We know that if we ever divide by a number that's greater than 1, we're going to get a smaller number, right? For example, if I divide by 6 by 3, I would get a smaller number than 6 too. But for this one, if we divide by a number that's smaller than 1, for example, if I divided by 6 by 1/2, because 1/2 is smaller than 1, then I would get 6 times 2, because when you're dividing by a fraction, it's just multiplying by the reciprocal of the fraction, right? So 6 divided by 1/2 is basically 12. So when you're dividing by a number that's smaller than 1, you always get a bigger number. And when you're dividing by a number that's bigger than 1, you'll get a smaller number. Okay, how do we use this to our advantage? Well, we know that x divided by 3, since we're dividing by a bigger number, this is going to get us a smaller number than whatever this is. All right, so that's out because we don't want a smaller number than this. We want the biggest number possible. And for d, we have 3 divided by x, and that's going to give us a really big number because we're multiplying by a small fraction, right? So the answer is going to be d. If I divided, if you really wanted to check, what you can do is you can convert this decimal to a fraction in a sense. So this will just be here with that many zeros behind it. And then we know that, sorry, we're dividing. This will equal 3 times the reciprocal of this, which is 1 followed by that many zeros. So this is going to be a huge number. All right, so the answer is D. And the main concept here that we're trying to go over is how when you divide by a number that's less than 1, so I'll bring that example up again. If you divide any number, for example 6, by a number that's less than 1, for example 1/2, you'll always get a number that's bigger than 6. So in this case, that's 12. And if you're dividing the number by a number that's greater than 1, for example 2, then you'll get a smaller number than 6. So that's something you should always remember. All right, we have one last problem and 2 minutes to do it. So the question asks, what number should be removed from the list so that the average of the remaining numbers is 6.1? Okay, so let's go over averages. How do we find an average of a list? Well, we find an average by adding all the numbers together and then dividing by the number of by the amount of numbers, right? So for example, so this is unrelated to the list. If I add the number 2, 4, and 8, for example, how do I find the average of this? Well, I would have to add the numbers, 2 plus 4 plus 8, and then divide by the amount of numbers, which is 3, because there's 3 numbers. And that would give me, 14 divided by 3, and this would be my average of this set of numbers. All right, so let's find the average of this set of numbers. So if we did some, I already wrote down the answer to this, but if we added all these numbers together, we would get 66. And then we have to divide by the amount of numbers in this. So let's count that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 numbers. So the average is 6. The average of this whole list is 6. But we want to remove one of the numbers so that the average of the remaining numbers is 6.1. So I'm going to use a little algebra for this. If we know that the average is just all the numbers added together divided by the amount of numbers, then I can set up a fraction. So I want the average to be 6.1. I know that the current average is 66. And I want to subtract a number from here. So I'm going to let that be x because we don't know the number. And then I'm going to divide that by the amount of numbers, which is 10. And the reason why it's 10 is because if I took away one of the numbers, then we would only have 10 left, right? We only have 11 currently. And if I took away 1, we would have 10. So now that I have this equation, I can solve for x. I multiply both sides by 10, get 61. Negative x equals -5. X equals 5. And there we go. The number that we subtract from 66 is 5. So we just take this one away, and the answer is B. Okay. Do we have any questions on that one? That one was a little bit confusing. Okay. So if you do have a question, keep typing. But that's all the time we have for today. So hope you guys learned something. Hope you guys got some practice in, and you may go. Thank you guys for coming. Bye, guys.